Morning guys, today we're going to take a more in-depth look at the case annealer and kind of go through some of the, just kind of explain better what's going on. We'll take a look at what's working, what's not working with it, show you some of the code. And again, this is very much a work in progress, but hopefully it'll help clear up some of the stuff that I've been talking about with some people. So yeah, let's go ahead and jump into it. All right, so here on the left side, obviously, is the code I've got at the top, and this is like incredibly entry-level Python stuff that I've pretty much just been able to pick apart from either Googling things and just learning a couple basics. I'm sure there's a ton of redundancies or ways that things could be done more efficiently. But I digress for the time being. So anyways, at the top, we're importing some of the stuff for the GPI pins, the time library, and then the display library. The first setup section we get to here, this is where we're going to call out what pin is doing what. So just to kind of explain that better, let me see if I can jump over. Here we go. All right. So we've got our Raspberry Pi Zero back here, and it's got just a pinout board that makes it really easy to tie into things so that we're not using DuPont connectors for everything. But like just for example, if it decides it ever wants to focus. To which it doesn't. Come on. Get out of here. All right, one second. Let's see. These Logitech cameras, sometimes their settings. It'll keep like 90% of the settings and just change a couple random things every time you reboot. Okay, there we go. All right, so if we're looking at this top guy, we can see that that's pin 16. And then if you look back here, this top GPIO setup, number 16, and we've got it commented out, but it's labeled, so that's our lower gate. So that GPIO pin is actually, it goes up here to our relay board, and I believe there's two greens just because I used two pieces of Cat6 here, but I believe it's either the first relay or second to last relay, but that's actually what controls the solenoid on the bottom here. And so then again, it's just kind of rinse and repeat for everything else. Looking back at the code over here, we've got the GPIO pin, GPIO, geez, that turns on the induction heater. So the actual unit is controlled via this giant solid state relay. And that's activated just for the precise amount of time that you enter at the beginning. So it's not controlled by releasing the brass quick enough to get it out of the coil. You know, a piece of brass can just go and sit in there all day long waiting, and then the relay actually turns on the induction board. So I was speaking to somebody and we were actually talking about just how to make it more of a closed loop where we're getting some feedback using some IR sensors. But right now it's just a time delay. So a piece of brass goes from, here, sorry, keep looking. Yeah, so right now a piece of brass will go from here into this gate. It'll fall into the coil, and then that coil will open up and it'll fall out. And this is all just time-based. So, you know, I've kind of figured out that, well, here, let's actually look at if you go back here to the code. So we've got all of our pins, then we've got a little bit of setup just so to get the display working, and then we've got these assigned values. So case count, how many cases we're annealing. Case count original, that just helps us do the countdown. You're essentially going to subtract the two, and that's how you'll kind of find out how many cases left. Coil time, that's another thing. So case count and coil time are the two values that it's actually going to ask you for and you'll assign. And then you've got top gate time. So top gate time is 0.3 seconds, and that's essentially just a sweet spot that I found. That's how long this top gate stays open in order to clear around without jamming or being open too long, or that just kind of seems like the sweet spot. Then we've got the bottom gate time, same thing, gives it a half a second right there to get the bottom, or for the bottom gate to open and get the brass out. Pump startup, 5 seconds. So this is a water-cooled setup. We've got obviously a radiator with some fans, and then we've got the water pump. So I gave it 5 seconds just to kind of, help get everything flowing before, rather than just turning the pump on instantly and starting to anneal, I wanted to get some water flowing. And then below that is pump shutdown. So same thing. So if you're unfamiliar, the way this works is, and again, this is going to probably be the very dumbed down, probably maybe somewhat wrong explanation. It's using eddy currents, and it's creating a high frequency electromagnetic field inside the other brass. It's kind of like having a transformer and you're shutting out the secondary coil. So this itself, I could have this on all day long and it's not actually going to produce any heat. The second you put a ferrous mantle inside of it, that's when you'll start getting the heat. So why is it water cooled? It doesn't produce any heat, but you are going to get radiant heat backwards from the metal while it's in there. That's been my understanding and so far that's proven true just in my kind of preliminary testing and playing with it. So either way, that's why there's some, one, that's why it's water cooled, and then that's why there's a pump startup and shutdown time just to help keep everything cool. If we keep going a little bit lower through the code, so I had this defined exit button callback, and what this was so I've got a little start button down here, just like a kind of, once you enter in the case count, the case time, you press this, it gets going. And I wanted to, as soon as that was done, I wanted to turn this into an emergency stop. And so I did an add event detect, and for whatever reason, there's some feedback somewhere in the system, and it's triggering that randomly, but pretty early on. So I've got it commented out right now while I kind of figure that. But essentially, if I was to press this, it would go ahead and it would set all these GPI pins to low, essentially turning them off, making sure the induction heater isn't on. I believe I had it set to keep the fans and the induction fans on as well, just as a kind of safety fallback. So after that, we actually get into some of kind of what I'd call like the active side of the program. So right off the bat, we're going to get a little message, and it says starting up. Here, let's actually go ahead and jump into, I think I typed that wrong. I did. I feel like I typed it right that time. Hey guys, come watch me learn how to type on a keyboard. Oh, jeez. I didn't have the Pi on. Oh. Alright, so give it a second to connect to Wi-Fi. It's early, still drinking some coffee. I know there's like load, save, and stored sessions. There's got to be a way to like not have to type this in every single time. Let me pull up on another screen real quick, take a look at my router and see if it's actually connected. Ah, there we go. All right, so then we can just go Python, oh shoot, ACF 2.3, I think is the version we're on. Yep, 2.3.py. All right, so let's turn this so you can get a better idea of what's going on the screen while we walk through this. I don't know if that's going to be too blown out. Stand by. There we go. Hopefully that'll see. All right, so we're going to go ahead and execute that first line of code, call up the program. All right, you can see we're getting this starting up, ACF Annealer. Goes blank for a second and shows a version number, then it starts asking us for our time. So if we jump back real quick to the code, we'll kind of follow along and see what happened there. So up here at the top, we got our starting up message right off the bat, and then it slept for a second, so it's essentially just a pause. We move our cursor for the LCD screen. It says ACF Annealer. We sleep for 2 more seconds. It clears the screen. We sleep for 2 more seconds. And then it says version, what version we're on. And then right here, it turns GPIO pin 19 high, which is on in our case. If you go back up to the top, number 19 is the induction fans. So those are the 2 fans that we are actually running up here on the ZVS board. And again, that was just kind of if the machine was on, I wanted those on. They're pretty quiet. They're not making much of a fuss. So it just kind of seems like a good plan to always have those ones on. Hopefully that clears up. Okay, so let's go back down to where we were. All right, so yeah, right here, GPIO pin 19 turned on, and it sleeps for 2 more seconds. So then we get into our first while statement. While. And it's essentially saying while the coil time is equal to 0, which it was, because that's what we had it set to. You know, when the program loads, it runs top to bottom. So it's going to run through here, and it's going to set all these variables to these numbers. So it's setting case count to 0. So the pi, right now, the pi goes, oh, the case count's 0. Cool. So we come down to our while statement, and it's essentially saying when the coil time and case time, I guess I'm kind of using these back out of order, when case count is equal to 0, which it is, we're going to go through and do this. If it's not, we'll go through and do the rest of that. So it's going to go through coil time. How long do you want to, it's going to ask us to set coil time, which is what we've also got on the screen right now. So over here on this side of the program, on the right side, it's our, you can see my mouse on the screen, but only when it's a mouse, not when it's a typing cursor. Interesting. Okay. Well, on the right side, it says set coil time. So we're going to go ahead and put 5 seconds in there. We'll hit enter. It's going to confirm that the coil timer is set to 5 seconds. And then it's going to ask us, how many cases do we want to anneal? And we'll go ahead and we'll say 500, just so this keeps running while we're, so, and it's set to anneal 500 cases. Now it's asking us to press the start button. So when we go back over here, we've got our coil time, while statement, and then it confirms right here. Then we've got our case count while statement, and then it confirms the case count here. And then we drop down into the start sequence. So LCD screen puts up the message, press start button. We get that print. So anytime you see print, that's going to print on a terminal, which is what you're looking at on the right side of the screen. And anything that's got the LCD.write, that's actually going to be printed on the actual LCD screen out here. So just that's kind of why you see the redundancy, or it looks like there's 2 things with the same message, but they're just going to different places. And then, so yeah, then we've got GPIO, wait for edge on the pin 4. So the way that we've got the start button put into the pins, it's just looking for the falling edge, meaning that once you push the button, it's going to start rather than waiting for you to push and release the button. That would be rising. So we're looking for falling, which is essentially as soon as the button gets pressed, it starts. You don't have to let it go for it to kick in. So what we're going to expect as soon as we do that, right off the bat, we're going to start turning on the cooling system. You're going to set pins 26 and 13 to high. Let me go back up here. We'll look. 26 is the radiator fans and 13 is the water pump. So those are controlled separately, but obviously that's both for the water cooling system. So back down here, 26 and 13 get set to high. And then we display a message that we're turning on the cooling system. And then we've got the sleep. So like you've seen before, like if you look right up a couple lines up, right here, we'll sleep for 3 seconds. We'll sleep for another 3 seconds. We can just put in an amount of seconds, or we can put in a variable right there. So time sleep, we did the pump startup, which is like we were talking about earlier. That's one of our variables we said. So I don't have to put 5 seconds in there. I can just put the variable name. And then later, if I want to come over here and change it to 10 seconds or 8 seconds or 7 seconds, I don't have to go through all the code looking for any time I used that 5 second. If I had it, the pump doesn't make a good example, but if you were going to use a variable in multiple spots, it's nice to have the variable up top called out rather than just putting 5 seconds manually in throughout your code and then having to go back and find and change each one of those. So hopefully that makes sense. Anyways, so we go to sleep for the 5 seconds. The screen clears itself. And then you see here we go, where we've got our case count orig, which was set to 0 up in the beginning. And now we're going to go ahead and set that to the case count that we entered, which is 500. So while the case count is greater than 0, we're going to go through this thing. And right now, at this point, the Pi thinks it's set to 500. So we're going to go through this a couple times. And essentially what's going to happen here is it's going to say annealing case blank out of blank. And right here, we're just doing some simple arithmetic, I don't even know if that's arithmetic, just to show how many we've done versus how many are left. And then we're going to go ahead and open the top gate. So we're going to set pin 20 high. We're going to sleep for that top gate time. And then we're going to set pin 20 to close. So the gate opens here, it waits for this long, and then it closes. Then we wait for 0.5 seconds, which you can see that we kind of call that as a stabilizing. So my idea there was that the case falls, and maybe it's kind of like not playing Plinko the whole way down, but it just gives it half a second for the case to settle, and it's not an instantaneous thing. You could do 10 seconds there, and it's going to function the same. It's just going to take longer for each case because you have this dwell period, essentially. So we wait. Okay, so I think it was the pin, the top gate closes, it waits, and then it does the stabilizing for 1.5 seconds. I don't know why I didn't combine those into one time sleep, but anyways. So then we turn the coil on for whatever set amount of time that we decided. So pin 21, go back up here to the top. GPIO pin 21, that's the induction board. Well, it's actually the relay that controls the induction board, but just for the sake of knowing what it does, that's what we called it. So that turns on for the set amount of coil time, then it turns right back off. Then we open the bottom gate, this guy down here. We open it and hold it open for the set amount of time that we've got the bottom gate time set to. And then the bottom gate closes, and then we wait for a second. Then we clear the LCD screen. Then we say, hey, we've done one case, so subtract that from our case count. And the way this whale statement works is, remember, anytime the case count is greater than 0, it's going to run through this repeatedly. It's just going to go up and down, up and down, up and down. So you don't have to, I don't know, that's just, I didn't make it, that's just how it works. And so once it gets to 0, then it'll kick through and finish what's down here, which it's going to say, hey, congratulations, we finished. And then it's going to go into cooling down mode, where again, we've got the pump shutdown time. So for 10 seconds after the last case was done, we're going to keep pumping water. We're going to have the radiator fans on. And then here, we're going to turn off the radiator. We're going to turn off the pump, and we're going to turn off the induction board fans. And then it's going to say, adios, good night. And it's going to do a GPI cleanup, which is just kind of like a housekeeping thing, putting everything back the way it found it. And then the program's done. And then we can either come back over here to the terminal and restart it, or run another program, or do whatever we want. So let's actually jump in for a minute and take a better look. I don't know what's going to be the best screen. Maybe we'll just do this. Let's actually just kind of run through. I'll let it start going here for a while, and we'll kind of spin it around and take a different look at what's happening with each thing. So up here on the board, you'll see that we do have 2 LED lights right now, and they're pretty blown out with the lighting. But this guy right here is a green LED, and that just means that the board has power. That doesn't mean that anything's happening. One of our red LEDs over here means that one of our relays is actually engaged or energized, and that would be the cooling fans for the ZVS board. So those black fans over here on the top side. That means, oh, that was good. That means those are on. So we've got our case time in, our case amount in. It's just wanting us to press the start button, which let's go ahead and do. Actually, real quick, so let's just talk about a couple of the issues that we are running into, just so we can know what's happening as soon as they start to happen. These linear solenoids, they've got a decent pull strength, but one of my main problems that I'm running into here is that the cases are actually, they're bunching up in the hopper. And so that's kind of why I made this block, which is just a focus there. It's just an added in piece that's not actually part of the hopper. And that was intended just to see if we could kind of reshape how they, stop the cases from coming in at both sides and jamming. But essentially, like if we knock a bunch of these down here, kind of act like they were all just stacked in there. Clear some out the bottom. Keep clearing them. Okay, so there you go. That's what's happening, where there's actually a small, you can see it, God, I don't know why the lighting's so bad, but you can see that the case gate in there is empty, and that the cases are all just bunched up right here. So I haven't figured out what I want to do to try and redesign. I like the gate idea. I know that there's another gentleman, I'm going to blank on what his name or handle or what any of that is. He had a rotating selector where it would just continuously rotate using just like a stepper motor. I think it's obviously a good idea. I don't know, I'm kind of set on making this work. I also kind of thought maybe doing like a snaking path where you don't ever have many cases on one. Like you essentially can just load 30 or 40 cases at a time, and they just wind down, but they stay in a single file line the whole time. I don't know if maybe the answer is to kind of have like a little slot that overhangs here that, cases can be, you can have more cases up here, and they kind of funnel off to this very edge and then run down. That I don't know. Problem number dos is this coil is way too big. So it does work. They do get hot. They get hot enough that I can't hold them. You'll see me probably burn myself here in a second. But it doesn't do it quick. Sometimes it's 15, 20 seconds. Where if I can get this coil turned down to, maybe twice the size of an actual piece of brass, it'll be just a couple mere seconds. The problem that I'm having is that since I'm also water cooling it, I need to be able to do that without kinking or breaking or pinching the copper. And there's a couple guys that have reached out and they gave me some really good ideas on filling the copper with either like a salt, which would be water soluble, so hopefully it'd be easy to flush out, water, or there was some other, I think it was like a casting metal, like something that essentially has a super low melting point that you can fill this with. It'll solidify. You can then bend the pipe around, a mandrel or whatever you're using, and it won't kink. And then you can essentially put the whole coil back in some boiling water and it'll melt out. I think all super good options. I just haven't had the chance to jump in and try that yet, but that's something that needs to happen. Another thing is that I do want to add a smaller water reservoir up here. This is just a CPU cooler that I'm using as a pump with the radiator and the fans, and I cut apart the hoses that came with it, and it was a sealed system where you're not intended to fill it or drain it or do anything like that. And I did, and now there's a couple places where there's some bubbles trapped, and I think having a small radiator up there would help flush those out. Once it gets running, you can see that it's circulating pretty good, so it's not a huge problem, but it is something that I would like to address just to keep fine-tuning it. I just soldered on. So I took some, I think they're I think the copper is 3/16, the tubing is 1/4, and I was able to get 1/4-inch barb fittings, cut them in half, bevel the inside, and solder it to the copper, and that actually worked pretty well. And we haven't had any, I didn't mean to show you that close-up of my soldering skills, but anyways, it hasn't leaked yet, so nana boo-boo. What else do we got going on here before we jump in? We do have 2 power supplies. We've got our main 48 volt, which runs solely the induction board. I think this is 1,800 watts, 1,000 watts, and the CVS board is like twice that. So we're definitely not running the induction board to its max, but that's not a bad thing, I think. And then we've got a 12 volt power supply that is running all of our low voltage electronics, our gates, all of this, the Pi. Oh, there's a step down to the Pi, but anyways, that is all of that. Actually, no, I take that back. I had a oh, come on. Come here. These things. What are they called? Somebody help me. I don't know. The board that steps down voltage. I'll yell it out in like 5 minutes to remember it. I was using one of those, but I had the cable that I had cut, the USB cable that I had cut, and then tried to solder to that. The wires were so small, and I kind of broke it, and it was finicky. So we're actually having 2 power supplies right now, just a dedicated one to the Pi itself, and then obviously the main one for the 2 power supplies. This is just a ground bar, so all the terminals on top are just linked together via this bottom bar, and they're just grounded to the 2 power supplies. Up top, that is our shunt. This guy back here, that's our shunt, which is working the voltage and amperage meter for the front. So it actually just kicked on by itself, and I think I touched something wrong, and like I said, so kind of the same situation I ran in that earlier with the add detect. It was looking for that falling edge, and if there's any background noise or anything going on, it can sometimes pick that up. So kind of a bummer that that happened on camera, but also kind of good that now you guys know what it's still very much a work in progress. We got bugs to fix. But we got that case jam still going on up there, but this is just kind of showing you the, sorry, let me find the perfect height. So you can hear, I don't know if you can hear, let me get my mic a little bit closer. The power supply, you can hear it ramp up every time the actual induction board turns on. So it's heating, bottom gate opens, feeds the top case, case falls in, that turns on. You see the amperage go up for 5 seconds because that's what we set it to. Board turns off, gate opens, rinse and repeat. If you come over here and look at our relay board, you'll kind of see the dancing lights. Well, everything's happening as well. So we've got our ZVS board fans. Oh, I got one that fed in there. Did it fix itself? ZVS board fans, water pump. Yeah, look, it kind of just fixed itself. Let's see. Hey. Yeah. See, it's not red hot, and it's pretty cool already, but they're definitely toasty. They're coming out pretty hot at only 5 seconds, but 5 seconds should be enough to pretty much anneal cases to a red hot. And obviously, once we get to that point, we'll use some temp black and really kind of try and get it dialed in. Focus. Hey, there you go. Okay, so ZVS fans. So those are the fans, those 2 black ones I stuck my finger in a minute ago. We have our water pump and our radiator fans. I don't remember exactly which one's which, but those are the 2 of those. This guy right here is our induction board. So this one turns on the main, this big solid state relay. This guy is our top gate, and that guy is our lower gate. So you can see top gate, induction, heating, heater turns off, bottom gate opens. Rinse and repeat. So our fans and our water pump will stay on this whole time, and these 3 will just sit there and work through their dance. And then down here, let's see. The screen doesn't show up super well. Like in person, it looks perfect. On camera, it looks like. So it is going to sit there and give us a running total too of how many cases we've got, how many cases are left. And then you can see this pinout breakout board down here. It's got little status LEDs kind of showing the same thing. A lot of them are going to stay lit because, hey, we got an actual case that came through. Yeah, so you'll see them kind of doing the same thing when the GPI pin goes high or low, or when it switches from what it's set to. You'll see some of those pins light up. The red ones are voltage, like some of them are just hot 3 volts, some of them are hot 5 volts. I think blue is hot 5 and red is 3, I don't know. And then there's a couple ground ones in there that I don't think are lit, but that is besides the point. Alright. So let's see if we can kind of... I have run into a couple little issues too, just where the gate's not strong enough to... It's raining cases. Just if there's a jam or anything like this, there's a case in there right now that's kind of sitting in there cattywampus. neck down, so to speak. There we go. All right. Oh, boo. Yeah, see, like, I also had a problem too. I have this slightly loose just because it was binding up. And maybe it's just moved around enough that it does actually have a little bit of play that needs to be taken back out of it. Yeah, it seems like if I hold the bat just taking a smidge off of it, it seems to do pretty good. Oh, that one missed altogether. Let's actually see real quick. So, and I just have two little holes right there where you can kind of adjust. Ah, see. No, it's not moving at all. Finicky. Not wanted to. Ah, there we go. All right, don't touch it. Ah. I think we were doing so well. See, I think another part of it too is just once there's enough brass up there, maybe it's a weight issue. And you can see, yeah, we're only using just over half of our available amperage. So I think getting that coil turned down quite a bit would help. Definitely, I'm happy with the bottom gate. There's just something going on up here that needs an elegant solution. Stronger solenoid, or just a better feeding system, something maybe closed system where we're getting some actual feedback on it. And I think so also there is a, sorry, let me, I did print and make a little spacer right there on the inside of the solenoid. I did that to increase the essentially like the kind of the preload on the spring. Just trying to kind of cheat and tune the system. I have a assortment of other springs that I tried using, and once you go even remotely just a little bit stiffer, it can't overdo it, or it can't overcome that, and then even just sitting on the bench, the solenoid doesn't work. So well, I thought we had it, but I said that like 6 times throughout this project, so. I don't know. Anyone got any ideas? It's hot. Yeah. Some sort of way just to easily feed one case. A stepper motor, that's a good idea, but then it gets out of my wheelhouse where we're starting to use steppers, and I know those can be, I think there's steppers that are and are not closed loop, where they provide feedback to kind of indicate what their actual position is. You could just have like the drum and it just does one revolution and there's a cutout, but that's essentially just taking that other guy's idea, which I get. It's all open source sharing. If someone took something of mine, I wouldn't care, but I do like trying to create a solution for what I've got. Well, I think that pretty much covers most of the nuances with it and how it's working, what it's doing, kind of what's going on. Hopefully there will be a breakthrough video here soon with some new confangled hopper. But until then, I think I'm going to go ahead and wrap this up. So appreciate you guys joining. Have a good one.